some questions that we will try to answer using computer visions. In this slide, I will tell you what questions can we answer about computer vision and using computer vision applications and what can we not. Although these points, they summarize what we are doing currently, but they are not limited. And there is a lot of research and development going on as we speak. So we'll be using all the applications that I mentioned just now to help you answer that which questions are exactly we are answering when we are talking about computer vision applications. In the application like a driverless car, we often use object classification to categorize the objects that we see on the road, like cars, pedestrians, road signs. We can have some roadblocks, we can have some trees, a curb, we can have some other vehicles. We have so much going on when we look at a road. And a computer vision algorithm that does an object classification can help us to decide what is, like, classify that there is a tree present in this photo and there is a car present in the photo. So these kinds of things, to classify some objects into the broad categories, we can do this using object classification, not only in driverless cars, but for example, if we have some kind of simple software that just says that is this photo is a dog, or is it a cat, is it a rabbit, that kind of classification to just say what this object is, very broad general term. These kinds of questions we can answer using computer vision. We can also do some object identification. For example, in insurance or in banking software applications, we discussed that we can identify a person using some images or videos. And this identification, they can also play a crucial role in surveillance system too. So these kinds of things we can do with computer vision systems, that is identifying an object. We can say that this photo is of Narendra Modi, or we can say that this photo is of Trump or Obama. We are identifying who that person is in that photo. Or we can, if you're looking at someone's passport, we can tell that this passport belongs to this person with so and so date of birth, and where that person lives, who is their parents or something, whatever the IDs that we have, we can identify using computer vision. We can also use computer vision to verify. When we are using someone's passport, or like looking at someone's passport, we can use computer vision to verify. Now, we will see that this might seem confusing, object identification and the difference between object verification. Using object identification, we sometimes don't have any prior information about what kind of objects there are in the photo, but when we are doing object verification, we must have we are comparing two things, like we're comparing the information that we have already about someone and verifying it with the thing that is present in the photograph. Like, for example, we can do verification of using like biometric systems, or we can do using someone's passport, these kinds of things. And we can use these identification and verification to build our application. Sometimes it goes hand in hand, so we think that there might not be any difference. It's just sounds very similar, but when we are developing the application, then we will realize the very slight difference between these things, like object classification, object identification, and verification. You can also do object detection. Object detection means that we are looking at a photograph and detecting potential objects. Suppose this is the photograph, we have a magnifying glass here, so we are detecting this part of photo as an object. This is called an object detection. We can use object detection in robotics, and we can use it in like detecting some kind of road signs. We can use a landmark. We can do some landmark detection also using some key points that are in the photograph. For example, if we are in a forest and there are a lot of trees and we want to know where we are, what we can do is label the trees as tree number 1, tree number 2, tree number 3, and we can just decide our position with respect to the trees. And we can say that if someone else is also in the forest and we're talking to them over the phone, we can say that, oh, I'm near the tree 1, and he can say that I'm near the tree 10. So what we have done is, using our own human visual systems, we have just used the trees as a landmark. When we are working with some robots, when we are working with some kind of drones or any system that uses movement and the need to do visual detection, we can use this landmark detection technique, and we can, using computer vision, we can answer what are the key points for an object, which could be us or anything, which could be a car. And we can say that these are the key points for that thing or a person in that photo. We can also do some object segmentation, and we can answer which pixels belong to which object in the image. For example, when we are doing object detection, we see that in this magnifying glass, these pixels that, if I hope you can see my pointer. I'm moving my pointer to point the circle of the magnifying glass. These pixels, they belong to this magnifying glass, and these other yellow pixels, although both are yellow, these belong to the magnifying glass, and these other pixels, they are just the background. So using object segmentation, we can see what kind of pixel belongs to the object and what kind of pixels don't belong to the object. And we can do some segmentation technique when we are talking about our applications in medical field, that is x-rays, identifying some x-rays or MRIs or other body scans, anything could be. We can use this object segmentation to answer a lot of things about that scan. We can tell about, for example, in x-ray, we can look at it and talk about some fractures. We can look at some MRIs, talk about some brain cells that are behaving abnormally, that's not consistent with the usual brain scans or something. And we can also answer questions related to object recognition. We can find the objects. That object could be anything. It doesn't necessarily have to be a person or a thing. It could also be, for example, some characters. We can look at a photo with some letters. For example, this PPT, we can look at this PPT and see what are the words, what are the letters, that this letter is O and this letter is B. We can see that the O is before B, and these kinds of things that we can answer using object recognition. It's called object recognition when we are answering these things. And these questions are the ones that we can answer using our computer vision applications. In all the applications that I mentioned previously, whether it be robotics, in government sector, in agriculture, in medical field, in retail industry, in manufacturing, all these applications in some way or the other way are using at least one of them, and some are even using all of them, some are using some of them. And while we are developing our applications, we have to answer some of these questions. So these are our current capabilities with computer vision system. Currently, we can answer these questions. Some of these questions we cannot answer with so much accuracy, but we are trying to build and develop more new systems with more efficiency and more accuracy. And so in the next slide, we will see how this computer vision works. So it's a three-step process. Like I explained to you about the human visual systems. We have an eye that captures the light. We have some receptors in our eyes that process the image and measure the intensity and these kinds of things that our receptors do. And then we have our brain, which has a visual cortex that can help us in understanding what that image is. Similarly, we have computer vision. In computer vision applications, first we acquire images. Images could be acquired with any camera or using some kind of machines, medical imaging machines. We can use photos and videos, and we can use 3D technology like RGBD cameras, or we can use thermal images. We have so many options for images right now. So this step is actually a lot easier than before. And then once we have an image, we have to process the image. And by processing the image, I mean that we can identify that there is some edges in the photo. There are some circles, some contours, some lines. We can also see that the image is colored image, or it's a black and white image, if it's what kind of color model it has. And while building some of the applications, we might need to process our image before going to the third step. So these processings we can do in this step. So we know that some deep learning models are used in the step 3 to understand the image, but we can also use them to automate process of training the images using a labeled and predefined images. And then after the output, we can understand that the image belongs to this class, or it is this object, these things. And we can use image processing tools, like some tools are available in OpenSea library, and these tools can help us like extract some features from the images. For example, if we have a face here and we have some eyes, one nose, and a mouth, then using this processing step, we can first extract the bigger circle, which is our face. Then we can extract the eyes, we can extract the mouth, and feed it to the third step. In understanding, we can run some deep learning models to check about the similarities, detect some patterns, and in the end we will be able to answer the questions that we had in our previous slide. We had a lot of questions, so those questions are answered in this step, where our object is identified, or it is classified, or it is verified, or it is recognized, all these things. In this step, we are also, what we're doing is we are applying a context to the image. We are what we're doing is applying a context, like I initially explained to you how the brain works. We apply a context, that this yellow figure in the image is a sun. We are identifying it. This identification and classification is applying context to the vision. So in the next slide, we will see some methods that we can use to do the operations on the images, and these methods of analysis that one can use to implement computer vision in their own applications too. So we have these methods. I will just tell you what these methods are and what they do. but we won't really go into the details of how to do these things. Like, for example, video motion analysis. We won't go into the detail of how to do it, but we will know that what it does. So when we use a video to estimate velocity of an object in the video or velocity of the camera, we are we must do video motion analysis. Like, if you're traveling on a highway and there is some speed limit, we can install some kind of high speed cameras that can monitor, just they will just capture the image of the car passing by, and they will tell us the speed, and they can also detect that the vehicle has the speed limit is going over the speed limit. Sometimes they can also capture your license plate, and you can also get some fine in the mail next morning. But good thing is we can regulate our traffic using this analysis. We a simpler application would be in a cricket field. When we are watching a match and players are like throwing balls or scoring a 6 or a 4, and if we want to calculate the speed with which the bowler bowled, we can use this video motion analysis to calculate the speed. We often use this to capture to do the post game analysis, and not just in cricket, in other sports too, like tennis or hockey or any other sport. We can do some image segmentation that we already discussed in the last slide. In what questions we can answer? We can answer questions about image segmentations. We can use image segmentation to differentiate between the image pixels or the background pixels. We can detect the pixels that are meaningful for us, for example, the lines that are meaningful for us, the curves that are meaningful for us. Overall, what we are doing is labeling the pixels that are meaningful to us, for example, a line or a curve, or is it just the background? These things we can answer using image segmentation. And what we can do is we can, if we apply this image segmentation to a stack of images, a lot of images, we can also do a 3D construction, scene construction. This is called scene construction or a 3D construction, where we have a lot of images and we are performing image segmentations. And what we do is identify some features in the image, we match the features in the image, and we can construct a scene from the image. We can, when we are using the pano feature in our phones, we capture images, and then we can construct a 360-degree view of our environment. And it is also very useful tool in medical imaging and in robotics. We can do image restoration, which is blurring or removing noise using some machine learning models, using some filters, using some image processing tools. Like, we all use Instagram or Facebook or Snapchat. In those applications, what we're doing is sometimes we restore the image, and we do some manipulations with the image. And this image restoration, it could be a useful method to implement those kinds of applications. And we have object detection. We can use this bounding box to identify the objects in the image. And we can identify everything that's inside the box using these bounding box. What these boxes do is just enclose the object in the box, and we can have the coordinates of the box, and we can say that the box is likely to be in the bounding box. We can detect the object, we can track the object, and we can use it in a lot of different applications. Next is facial recognition systems. So facial recognition systems are actually, they are like object detection systems. They are like a subcategory of object detection. What we're doing is we are just identifying a human face, and by doing that we are trying to identify the individual. We try to recognize the facial expressions under different lighting conditions. Okay, so what were we discussing? We were discussing about some methods of analysis that we can perform on our images to apply it to some applications. Like we can do facial recognition, we can do edge detection. We were on facial recognition. We can do facial recognition on a human face under different illumination. And what we can do is change the image properties that account for, suppose, the pose alignment of the face, size of the face, or photographic properties like making it grayscale, making it color. And we can do feature extraction. And by feature extraction, I mean that we can look at the face and tell that there is the eyes and there is nose and this is the mouth. That I explained it to you in the previous slide too. And we have some edge detection techniques. And edge detection techniques, they are used to identify any object, the edge of the object, or any lines or curves that we have in our image. It's actually, when we talk about detecting an object, first we need to do the edge detection. We should do we can detect these edges using some CNN, which is convolution neural networks. We can use some image processing filters like Sobel filter. We have Kenny edge detection filters to detect the edges. They help us in detecting the objects better. So all these tools, they come under the bundle of edge detection. Then we have pattern detection. We can, by pattern detection, we mean that we can recognize the repeated shapes, colors, or other visual indicators in the image. We can detect some pattern, and these pattern detection often help us in finding if there is an anomaly. For example, when we talk about the application of computer vision in medical imaging, we can see that using pattern detection, that if things are okay or if there is some kind of anomaly going on in our scan. We can use feature matching. Is actually pattern detection, but what it does is it divides images into features, and then we match the similarities within a feature, within an image. And then we can we can use to classify some images, or this can also be used to minimize the noise or denoising an image. For example, if we want to detect some words on an image, what we need to do is reject rest of the background. We only need suppose if there's a piece of paper in the image that has some words in it, we need to reject the background. We only need the words, so we can extract some features from the image, and then we can do some feature matching. And this is an analysis method that we can use in our computer vision applications. Some of the applications may use only some of these techniques, but most of the applications and advanced applications rely on multiple techniques to accomplish their goals. Like applications like self-driving cars or drones or medical imaging, or all the applications that we have discussed today, most of them use a lot of these techniques. So now that we are done with these techniques, we have state-of-art technology that I would like to discuss with you today. These technologies are currently being used by companies like Google or Amazon or Bosch or Tesla or any other company that works in the vision. They are using these techniques. Most popular is convolution neural networks. And to understand convolution neural networks, you should know a little bit about neural networks. What are neural networks? Neural networks are basically, they are made up of neurons, the elements that behave like neurons, and they take some signal, they process it, and they feed it into some other layer. Like these are the neurons, and they take some input and they process it, and then they feed it into the next layer. So the network that is made up of these small elements that act like neurons is called a neural network. And they have some weights and some biases that we can adjust, make them learn over time, and hence we train a neural network model. And after we train a model, initially these weights and biases are zero, so they can give you whatever you feed into them. They can give you some output that's garbage, it's not related to what you want them to do. But over time, with multiple training images, we can train them to predict the output the way we want. Like, to if we feed them, if we feed these models images of birds, of trees, of, for example, dogs, and these images are annotated. By annotation, I mean we label them, that this image is of a tree. We are labeling it and we are feeding it to the network. Then after some images of training it for some time, we can make it a model, and we can test it using some testing set, and use their output. We can evaluate them. And about CNN, so CNN is actually, it is a type of neural network, and it can take some images, it can predict our output with more accuracy than even the humans. For example, if we have a photo of some similar looking things, we might make an error. But with enough training, these CNN, they have accuracy of about like 99% or something. We can, it depends on how much you train and what kind of data you're training.